Preparing for a solutions engineer at Akamai interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you design an Akamai solution for a customer experiencing high global latency? I would begin by clarifying the customer's business goal, such as reducing origin latency or absorbing a traffic spike. Then I would map requirements to Akamai capabilities, CDN caching, DNS, security, and edge compute. I would validate assumptions with traffic patterns, origin constraints, and success metrics. Finally, I would propose a phased architecture, demonstrate it with measurable tests, and explain operational trade-offs clearly. While answering, focus on discovering business goals, analyzing geographic traffic, selecting CDN caching, optimizing origin connectivity, defining latency metrics, and explaining how you would validate the recommendation through testing. Question 2. Explain how a content delivery network works and why Akamai is valuable to customers. A CDN places content closer to users at geographically distributed edge locations. DNS or request routing systems direct each request toward an appropriate edge, where cached objects can be served without contacting the origin. On a miss, the edge retrieves, stores, and returns the content. Akamai adds global scale, reliability, security, and visibility, helping customers improve user experience while reducing origin bandwidth and infrastructure pressure. Make sure to cover edge locations, DNS or request routing, caching, origin shielding, cache misses, availability, performance improvement, and the business value of reducing distance between users and content. Question 3. How would you troubleshoot poor application performance for a customer using Akamai? I would separate total latency into client, network, edge processing, and origin components. I would inspect Akamai logs, cache hit ratios, response codes, time to first byte, and regional patterns, then compare affected requests with healthy ones. I would test representative URLs from multiple locations and verify DNS, TLS, routing, and origin behavior. The goal is to identify the bottleneck, apply the smallest safe change, and confirm improvement with before and after metrics. In your answer, discuss isolating client, edge, network, and origin latency, reviewing logs and telemetry, checking cache behavior, reproducing geographically, and communicating findings with evidence rather than assumptions. Question 4. What is the difference between a cache hit and a cache miss, and how would you improve cache efficiency? A cache hit means the edge can serve a valid object locally. A miss requires retrieving it from the origin. I improve efficiency by designing stable cache keys, setting appropriate TTLs, removing unnecessary query string variation, and using versioned assets for safe updates. I also separate personalized content from cacheable content and monitor hit ratio, origin offload, and freshness. Aggressive caching improves performance, but incorrect rules can expose stale or private data. Be sure to mention cache keys, TTLs, cache control headers, query strings, cookies, purging, content versioning, hit ratio, freshness, and the risk of serving stale or personalized data. Question 5. How would you explain Akamai WAF to a non-technical customer? I would describe the WAF as a security checkpoint in front of the application. It examines web requests and blocks patterns associated with attacks such as SQL injection or cross-site scripting before they reach the origin. I would start in a monitoring mode, review legitimate traffic and false positives, tune rules with the customer's team, and then enforce blocking gradually. This reduces risk while protecting availability and preserving legitimate user access. Focus on translating technical controls into business outcomes, explaining HTTP inspection, rule sets, false positives, monitoring, tuning, blocking modes, and protection against common web application attacks. Question 6. How would you design a DDoS protection strategy using Akamai services? I would first classify the customer's exposure across network, transport, and application layers, then establish normal traffic baselines. Akamai's distributed edge can absorb volumetric attacks, while WAF rules, rate controls, and bot controls address application abuse. I would restrict direct origin access, define alert thresholds, and create an incident runbook with contacts and escalation paths. The design must preserve legitimate traffic, so I would validate controls through controlled tests and continuous monitoring. Make sure to cover attack layers, volumetric and application attacks, edge absorption, rate controls, origin protection, traffic baselines, runbooks, escalation, and testing without disrupting legitimate traffic. Question 7. What questions would you ask during a customer discovery session for an Akamai implementation? I would ask what business outcome matters most, which users and regions are affected, and how performance or security is measured today. I would map applications, APIs, origins, DNS, deployment processes, traffic peaks, and current incidents. I would also ask about compliance, ownership, timelines, integrations, and change management constraints. Those answers let me distinguish urgent symptoms from root requirements and shape a solution the customer can actually operate. In your answer, include business objectives, users and regions, traffic patterns, application architecture, origins, security incidents, compliance needs, constraints, stakeholders, timelines, and measurable success criteria. Question 8. How would you handle a customer who wants to cache personalized pages? I would first determine whether personalization is truly per user or only segmented by a small, safe audience group. Shared caching of user-specific responses can leak private data, especially when cookies or authorization headers are ignored. I would cache common page shells, bypass sensitive responses, and move personalization to client-side calls or controlled edge logic. I would verify cache keys and headers, test multiple identities, and document the security boundary before production. Be sure to discuss confidentiality, shared cache risks, session identifiers, cookie variation, edge-side logic, private caching, API separation, cache bypass, and testing for data leakage. Question 9. Describe how you would approach migrating a customer's traffic to Akamai. I would inventory domains, applications, origins, certificates, traffic patterns, and dependencies before creating the configuration. I would test behavior in staging, validate headers, caching, redirects, security rules, and observability, then run a limited canary through controlled DNS changes. During cutover, I would monitor errors, latency, origin load, and business transactions. I would keep rollback instructions ready, lower DNS TTL beforehand, and coordinate every change with owners. Cover inventory, DNS and certificate planning, property configuration, staging, canary traffic, rollback, monitoring, stakeholder communication, TTL management, and minimizing customer visible risk during cutover. Question 10. What is edge computing, and when would you recommend using Akamai Edge capabilities? Edge computing runs selected logic near users instead of sending every request to a centralized origin. I would recommend it for latency-sensitive transformations, routing, lightweight authorization, experimentation, personalization, or API mediation. I would keep stateful, compute-heavy, or highly coupled workflows at the origin unless edge execution clearly improves the design. The decision depends on latency targets, data locality, operational complexity, execution limits, and the customer's deployment model. While answering, explain computation near users, latency reduction, request transformation, personalization, authentication, lightweight business logic, deployment limits, observability, and when origin-based processing remains preferable. Question 11. How would you compare Akamai Bot Manager with a basic IP-based rate limiter? An IP rate limiter counts requests from an address, so it is simple and inexpensive but easy to evade with proxies or distributed automation. Bot protection can combine behavioral signals, device characteristics, reputation, request patterns, and challenge outcomes to identify automation more accurately. I would use rate limiting for broad volumetric control and bot detection for nuanced abuse such as scraping or credential attacks. Layering both provides stronger protection, provided false positives are carefully monitored. Mention behavioral detection, device signals, automation patterns, IP reputation, distributed bots, false positives, rate thresholds, credential abuse, and why layered controls provide stronger protection. Question 12. How would you respond if an Akamai security rule blocks legitimate customer traffic? I would treat availability as urgent while preserving evidence. I would collect request IDs, timestamps, regions, user actions, response codes, and the triggered rule, then reproduce the behavior safely. Rather than disabling broad protection, I would apply a narrowly scoped exception based on path, parameter, or trusted condition. I would monitor the change, confirm legitimate flows, review security impact, and document a permanent tuning decision with rollback steps. Focus on incident triage, request IDs, rule identification, logs, reproduction, temporary exceptions, narrowly scoped tuning, monitoring, rollback, and balancing availability against security protection. Question 13. How would you communicate a complex Akamai architecture to an executive stakeholder? I would lead with the business problem and measurable outcome. Faster experiences, fewer outages, lower origin cost, or reduced attack exposure. A simple diagram would show users, Akamai Edge services, security controls, and the origin, without unnecessary product terminology. I would explain the investment, risks, timeline, and success metrics in business language. Then I would offer a technical deep dive separately for architects and operators who need implementation detail. In your answer, emphasize business outcomes first, use a simple diagram, connect components to risks and metrics, explain investment and trade-offs, and reserve implementation detail for technical stakeholders. Question 14. Tell me about a time you influenced a customer or internal team without direct authority. In one project, a team resisted a caching change because they feared stale customer data. I mapped the data flows, identified which responses were genuinely immutable, and proposed versioned assets plus a short pilot. We measured hit ratio, origin load, freshness, and user errors together. The pilot reduced origin traffic without incidents, so the team adopted the approach. I learned that influence comes from shared evidence, safe experimentation, and respecting valid concerns. Be sure to structure the story with situation, stakeholders, conflicting priorities, technical evidence, communication, compromise, measurable result, and what you learned about influence and ownership. Question 15. How would you design observability for an Akamai-backed application? I would combine edge logs, origin telemetry, security events, and business metrics rather than relying on one dashboard. Key signals include P50 and P95 latency, error rates, cache hit ratio, origin load, DNS and TLS failures, blocked requests, and conversion impact. Correlation IDs should connect edge requests to origin traces. Alerts need meaningful thresholds and owners, while dashboards should distinguish regional issues, customer behavior, and platform-wide incidents. Cover edge and origin logs, latency percentiles, status codes, cache metrics, security events, business KPIs, dashboards, alert thresholds, correlation identifiers, retention, and actionable incident workflows. Question 16. How would you troubleshoot intermittent 5xx errors after placing an application behind Akamai? I would determine whether the 5xx responses originate at the edge or the customer's origin by examining response headers, logs, timing, and request identifiers. Next, I would compare affected regions, URLs, methods, and time windows, then inspect origin saturation, connection limits, timeouts, TLS, routing, and recent configuration changes. I would reproduce a failing request, apply a reversible mitigation if needed, and confirm recovery through error rate and transaction monitoring. Discuss separating edge-generated and origin-generated errors, checking timeouts, connection limits, health, headers, routing, retries, regional patterns, logs, recent changes, and safe rollback or mitigation. Question 17. How would you evaluate whether a customer's API traffic is suitable for CDN acceleration? I would not assume every API should be cached. I would examine methods, authorization, response variability, freshness requirements, headers, user privacy, and business consequences of stale data. Public, read-heavy endpoints may benefit from caching, while personalized or transactional operations usually need pass-through acceleration, connection optimization, and security controls. I would measure latency, origin load, cacheability, and error behavior, then recommend endpoint-specific policies rather than one global rule. Make sure to assess cacheability, authentication, methods, response variability, latency, rate limits, consistency, privacy, invalidation, origin capacity, and whether acceleration or security value exists without caching. Question 18. What is your approach to managing TLS certificates and HTTPS at the edge? I would inventory host names, certificate ownership, renewal responsibilities, and origin TLS requirements before deployment. At the edge, I would enforce modern TLS versions and appropriate cipher policies while maintaining compatibility with supported clients. I would automate renewal, monitor expiration and handshake failures, and test certificate rotation before it becomes urgent. Encryption should continue to the origin when required, with certificate validation configured correctly. Careful lifecycle management prevents avoidable outages. Mention certificate ownership, SANs and wildcards, renewal automation, TLS versions, cipher policies, origin encryption, certificate validation, monitoring, rotation, and avoiding outages during changes. Question 19. How would you build a proof of concept for an Akamai solution? I would choose one representative application path and define measurable goals before configuring anything. Baselines might include latency, cache hit ratio, origin bandwidth, error rate, and attack detection. I would implement the minimum property configuration in a controlled environment, test normal and adverse traffic, and compare results with the baseline. Throughout the proof of concept, I would involve operations and security stakeholders. The final recommendation would state benefits, limitations, costs, and production prerequisites. Focus on a narrow customer problem, baseline measurements, success criteria, representative traffic, staged configuration, security and performance validation, stakeholder feedback, and a clear production readiness decision. Question 20. Why do you want to be a solutions engineer at Akamai? I want this role because it combines deep technology with direct customer impact. Akamai operates at the intersection of internet performance, distributed systems, and cybersecurity, where thoughtful architecture can improve both user experience and resilience. I enjoy translating ambiguous requirements into practical designs, explaining trade-offs to different audiences, and validating outcomes with data. The solutions engineer role would let me keep learning while helping customers use Akamai's global edge platform effectively. In your answer, connect customer-facing problem-solving with distributed systems, internet performance, cybersecurity, technical communication, learning, measurable impact, and Akamai's global edge platform. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.